Hi everybody. Now in this video we'll learn the next 20 examples from the CET mathematics. Now let us start. Now the first question is, if f of x is equals to 1 plus mod of sin x bracket raised to a upon mod of sin x, where the x lies between minus pi by 2 to 0 and equal to b when x is equals to 0. And next is, that is a e raised to tan of 2x upon tan of, and f of x is equals to e raised to tan of 2x upon tan of 3x, where x lies between 0 to pi by 6, is continuous at x is equals to 0. Find the value of a and b. Now the given function is continuous, therefore its left limit is equals to the right limit is equals to the value of the function. Now where the here function breaks, the function breaks here at the point 0. Now here we will find out the left limit for this function, because this x is less than 0, and here we will find out the right limit here because this x is greater than 0. Now let us start. Limit x tends to the left limit, f of x is equals to limit x tends to right limit is equals to the value of the function, that is f of 0 is equals to 0. Now we will find out the left limit, that is the limit x tends to 0, 1 plus mod of sin x raised to a upon mod of sin x, that is equals to again limit x tends to 0, e raised to tan of 2x upon tan of 3x. Now this is very simple, that is when x tends to 0, 1 plus x raised to 1 upon x, the value of this limit is e. In the same manner, that is we can write here, that is the limit x tends to 0, 1 plus mod of sin x bracket raised to 1 upon sin x and whole raised to a, that is we can adjust here. And again the next limit x tends to 0, that is e raised to tan of 2x, here we require the 2x, that is divided by 2x, and here tan of 3x, therefore here we require this 3x. But what is the extra term? The extra term, that is a 2, here is a 2 balance here, and 3 is a divided by 3. Therefore now we'll see the value of this limit is e, and there is a e raised to a. Again for this limit, that is e raised to 2 by 3, which is equals to f of 0. Now we'll see this here, that is what is the value of a, that is e raised to a is equals to e raised to 2 by 3. Therefore the value of the a is 2 upon 3. But what about the value of b? Now here b is equals to e raised to 2 by 3, and hence answer, that is a c, that is a 2 by 3 and e raised to 2 upon 3. Now next question, if f of x is equals to e raised to x into g of x, g of 0 is 2 and g dash of 0 is 1, then find f dash of 0. Now this is function, that is f of x is equals to e raised to x into g of x. Now differentiate on both sides, that is f dash of x is equals to, using the product rule, e raised to x g dash of x, that is the first of all find out the derivative of the g of x, which is a g dash of x, plus derivative of e raised to x and keep g of x as it is, that is the derivative of e raised to x is e raised to x dot g of x. Now replace this x by the 0, therefore the f dash of 0 is equals to e raised to 0, that is x is replaced by 0, e raised to 0 g dash of 0 plus e raised to 0 g of 0, and then you will get 1 dot 1 plus 1 dot 2, that is 1 plus 2, that is equals to 3, and hence f dash of 0 is 3, hence the second option, that is the answer is 3. Now next, if a, b, c and d are the positive, then limit x tends to infinity in bracket 1 plus 1 upon a plus bx bracket raised to c plus dx is equals to. Now again this is very simple limit, that is this is the formula of the type, that is the limit x tends to infinity 1 plus 1 upon x and bracket raised to x, that is equals to e. That is the same thing is here, that is L is equals to limit x tends to infinity 1 plus 1 upon a plus bx. Now bracket terms, that is exponent must be the a plus bx. Now here adjust here, that is a plus bx to the numerator, and it is adjusted by the divided c plus dx divided by a plus bx. Now what is the value of this limit? The value of this limit is again e. But what about the next? that is c plus dx upon a plus bx. To solve this limit, divide numerator and denominator by x, that is a c upon x plus d upon a upon x plus b. The value of this limit is e, and e raised to this becomes 0. That is 1 upon c upon very large quantity. As x tends to infinity, this becomes 0. 0 plus d is d, and 0 plus b is b. Therefore, e raised to d upon b, and hence L is equals to e raised to d upon b. Therefore, the first option is correct one. Now next, let f of x plus y is equals to f of x dot f of y for every x and y belongs to the set of real number. Suppose that f of 3 is equals to 3 and f dash of 0 is 11. Then find f dash of 3 is given by the definition of the first principle, that is f dash of x is equals to limit x tends to 0 f of x plus h minus f of x upon h, and by the same thing is here, that is f dash of 3 is equals to limit x tends to 0 f of 3 plus h minus f of 3 upon h. Now what is the function? That is, we have given that is f of x plus y is equals to f of x into f of y, that is f of 3 into f of h minus f of 3. Now here again, by substituting the values, then you will get, here is f of 3 and f of 3. Take f of 3 is common, which is a constant, and it does not contain the h terms. Therefore, f of 3 into limit x tends to 0 f of h minus 1 upon h. And now by applying the L'Hospital's rule, that is the differentiate numerator and the denominator, f of h, the derivative is f dash of h, and the derivative of h is 1. Therefore, limit x tends to 0 f dash of h. Now, therefore, what is the value? As h tends to 0, then you will get f dash of 0. But what is the value of f dash of 0? It is the 11. And therefore, 3 into, it is a given, that is a 3 into 11, that is equals to 33. And hence, f dash of 3 is equals to 33. Now next question, if the g of x is equals to minus in under root of 25 minus x square, then limit x tends to 1, g of x minus g of 1 upon x minus 1 is given by. Now here again, by using the first principle, that is a x, limit x tends to 1, g of x minus g of 1 upon x minus 1 is equals to limit x tends to 1, that is nothing but the g dash of x. Now what is the derivative of, what is the g of x? That is the g of x is given, that is the minus in under root of 25 minus x square, and its a derivative is limit x tends to 1, that is its a derivative is 1 upon minus 2 times in under root of 25 minus x square into, because this is a composite function, the derivative of 25 minus x square is, 25 is a constant, and minus x square, this derivative is minus 2x. And after the simplification, that is as limit x tends to 1, then minus 2 into 1, that is a minus 2, and here is again 1, that is a minus 1 upon 2 in under root of 25 minus 1, that is a 24. And this minus 2 and this minus 2 get cancelled, and then you are getting, that is a 1 upon root of 24, and hence the option is here. Now next, if E1 and E2 are represent the eccentricity of the curves, that is x square upon a square minus y square upon b square is equals to 1, and the y square upon b square minus x square upon a square is equals to 1 respectively, then prove that. Then find the value of, that is 1 upon E1 square plus 1 upon E2 square is equals to. Now these are the eccentricities, these are the equations of the hyperbola, and we will find out, we will write the formula for their eccentricity and calculate it. Now these are the hyperbolas, that is a x square upon x square minus y square upon b square is equals to 1, and y square upon b square minus x square upon a square, that is equals to 1. Now what is the formula for, that is a b square is equals to a square in bracket e1 square minus 1. For the same thing for the second hyperbola, that is a square is equals to b square in bracket e2 square minus 1. Now these are the formulas for the b square and the a square, these two hyperbola. Let's remember this. Now find out the value of the e1 square. Now simplify this. This is a multiplied, that is a square, it is a divided by. that is a b square upon a square, this minus 1, it becomes the plus 1. Therefore, the even square is equals to b square upon a square plus 1. And the same thing is here, that is e2 square is equals to a square upon b square plus 1. Now again we will simplify this, that is the even square is equals to a square plus b square upon a square, and e2 square is equals to a square plus b square upon b square. Now that is we want to find out that is 1 upon e square plus 1 upon e2 square, that is the reciprocal of this. It is written as that is a square upon a square plus b square upon a square plus b square, and that is equals to 1, and hence the value of 1 upon e1 square plus 1 upon e2 square, that is equals to 1. Now next problem is, if the two dice are thrown together, then the probability that the sum of the numbers appearing on them is a prime number is. Now we will see this, that is n of s is equals to 36. When the two dice are thrown, then we get the n of s is 36. Then what should be the sum? Their sum is start from the 2 to the last is 12, but the numbers must be the prime. That's a 2, 3, 5, 7 and the 11. Then what will the event? That is the number should be the prime. Then how many? That is you will get n of a is equals to 15, and it's a probability, that is a p of a is equals to n of a upon n of s, that is a 15 upon 36. You can calculate, that is the prime numbers. Here we get that is the first prime number, that is 1 1, then you will get 1 2, then you will get 3, and in this way you can find out this number, that is n of a is equals to 15. Now next, let a is equals to, this is the determinant, that is a cos theta minus sin theta and the cos theta, then find the inverse of it. Again always use the that is a method to solve, to find out the inverse, because the answer is given here by the elimination method. Now first of all find out the its a determinant by using the adjoint method. What you will get, that is a minus cos square theta, and here is a minus sin square theta. Take minus sin as common, and then you will get the determinant of is equals to minus 1. Now find out, that is the cos of theta. The cofactors of the cos of theta, that is the cos of theta is a minus cos theta, and that minus minus will become plus, and hence that is the first term will be the cos theta, and that is the plus cos theta. Therefore the first option is correct, and hence therefore we will always apply the elimination method. That is, again I am repeating again, that is its a determinant is minus 1, and find out the cofactor of the cos theta. What is the cofactor of the cos theta? Is a minus cos theta, but the negative sign, what is the A inverse? A inverse is equals to 1 upon determinant of A into adjoint of A. That is I will get the minus cos theta, and that again the value of that determinant, it has the negative sign, it become positive sign. That is, therefore this is the option A, which is the correct one by using the elimination method. Now again the question from the logic, that is the output of the following circuit is, that is the circuit is given in this manner. There is a P and the negation P, and it is in the series. Now find out this, that is a P or the negation of P and Q, then you will get. That is for this circuit we see that these two are in the series, they are joined by the and these are two parallel, therefore P or the negation of P and the Q. Now what is the value of that? Is a P and negation of P is a T and Q, it depends on the Q, hence the B option is correct. The maximum value of the objective function, that is a Z is equals to 3x plus 2y for the linear constant, that is x plus y less than 7 and 2x plus 3y is less than or equal to 16. X and y both are the positive and the greater than 0 is. Now this is again very simple question, always find out, that is x plus y is equals to 7. When this line touches the x-axis, its a y coordinate is 0, therefore the point is 7 0, and when it touches the y-axis, its a x coordinate is 0 and the point is 0 7. To find out the point of intersection, that is a 2x plus 3y is equals to 16 and x plus y is equals to 7, solve these two equations simultaneously, then you will get the point B 5 2. And when this again the line touches the x-axis, then you will get the point. When this line touches the y-axis, you will get the point. That is, put here x is equals to 0, y is equals to 16 upon 3. Therefore, this is A point. This is the B point, their point of intersection, solve it simultaneously. And again, this line, when it touches to the x-axis, 7, 0, and the origin. This is the feasible region, and check the point. That is a 0, 0, A, B, and the C. Then you will get, that is for the 0, 0, that is 0, and for the point A, 16 upon 3, z is equals to 3x plus 2y. Then you are getting the z is equals to 32 upon 3. At the point B, 5, 2, z is equals to 3x plus 2y. Substitute the value of z is equals to 3x plus 2y. Substitute the value, that is x is equals to 3 and y is equals to 2. Then 15 plus 4, that is a 19. At the point C, 7 and 0, that is z is equals to 3x plus 2y. Substitute x is equals to 7 and y 0. Then z is equals to 21. Therefore, the maximum value of the z is at 21. Form the differential equation of all the family of the lines, that is y is equals to mx plus 4 upon m, and it is given by the eliminating the arbitrary constant m is. Now here there is one arbitrary constant. Therefore, what is the order of the differential equation? Is 1. Now this is eliminated because its order is 2. Now again, this is possible or this is possible. But what about this? This is not possible because the equation contains the other terms also. Now we'll solve this. Now y is equals to mx plus 4 upon. Now differentiate with respect to x. Therefore, dy by dx is equals to derivative of mx. The derivative of x is 1. 4 upon m is a constant, and hence the dy by dx is equals to. Put in equation number 1. That is, this is equation number 1. Substitute the value of m. That is, a y is equals to. Okay, that is, a y is equals to the value of the m is a dy by dx. That is, the x into dy by dx plus 4 upon m means what? The y m is equals to dy by dx. That is a 4 upon dy by dx. Then you will get, now simplify this, multiply on both sides by dy by dx. Then you will get y into dy by dx is equals to x into dy by dx square bracket square plus 4. Now simplify, adjust it like this. That is x into dy by dx bracket square minus y into dy by dx plus 4 equals to 0. Hence the B option is correct. The focal, now next problem, the focal distance of a point P on the parabola y square is equals to 12x if the ordinate of P is 6. Now in the conic sections we treat as, or in coordinate geometry, abscissa means what? X coordinate, and the ordinate means y coordinate. Now see this. This is a parabola of the form y square is equals to 4ax, that is equals to 12x. Now after the simplifying, you will get the value of a is equals to 3. For the point pxy, y is equals to 6, which is the ordinate. It lies on the parabola, and after simplification, you are getting the x is equals to 3. Now always find out the focal distance. To find out the focal distance, that is sp is equals to pm. That is the focal distance at the mod of x1 plus a. But what is the value of x? X1 is 3, and the value of a is also 3. Therefore, the focal distance, that is equals to 6. Focus of the hyperbola is plus or minus 3, 0, and the equation of the tangent is 2x plus y is equals to 4. Find the equation of the hyperbola. Now we have given the focus of the hyperbola, and the focus is always treated as plus or minus a, 0. Now for the hyperbola, x square upon a square minus y square upon b square is equals to 1. Its focus is plus or minus a, 0. Now the equation of the tangent in terms of the slope. That is, this is also the condition, that is c is equals to plus or minus in under root of a square m square minus b square. That is a given point, that is a plus or minus a, 0. This is the focus. Now squaring on both sides, that is a is equals to 3, that is a square is equals to 3. Now again there is one more formula for the eccentricity of the hyperbola. That is a e is equals to in under root of a square plus b square upon a square. Also, that is a square plus b square is equals to a square e square, and the value of the a square e square is a 9. It means that you have the equation a square plus b square is equals to 9. Now what about the equation of the tangent? The equation of the given tangent is 2x plus y minus 4 equals to 0. Now write this equation in the form y is equals to mx plus c. Now what is the equation of the tangent in terms of the slope? This is a c is equals to plus or minus in under root of a square minus b square. Now see this here. After the complete squaring, that is a c square is equals to a square m square minus b square. Now substitute the value of the c. What is a c? C is a 4 here. That is a 4 square a square, and the value of the m is equals to minus 2. M is equals to minus 2 and c is equals to 4. Substitute here. You will get 4 square is equals to a square minus 2 bracket square minus b square, and therefore you will get 4 a square minus b square is equals to 16. Now you have the two equations, that is a square plus b square equals to 9, and another equation, that is a 4a square minus b square is equals to 16. This is the equation number 2. Solve these two equations, then you will get a square is equals to 5 and b square is equals to 4. Therefore the equation of the hyperbola is x square upon a square, that is a 5 minus y square upon b square, that is 4, that is equals to 1. And hence, now next, therefore the equation of the hyperbola is 4x square minus 5y square equals to 20. Now next question, if 4x minus 3y plus k is equals to 0 touches the ellipse, 5x square plus 9y square is equals to 45, then k is equals to the value of the k. Now see this, the equation of the ellipse is x square upon a square plus y square upon b square is equals to 1. If the line y is equals to mx plus c is a tangent, then the condition of the tangent c is given by, that is a c is equals to, that is we treat as plus or minus, that is a c is equals to in under root of a square m square plus b square. Now see this ellipse, the value of the a square is a 9, therefore a is equals to 3, and the value of the b square is equals to 5. Now see this, that is a 4x minus 3y plus k equals to 0. Write this equation in terms of the y is equals to mx plus c. Therefore here a square is 9, b square is 5, m is equals to the slope, c is equals to k upon 3. Now the condition, that is a c is equals to plus or minus in under root of a square m square plus b square. Substitute the value of, that is c is a k by 3 plus or minus in under root of 9 into 4 upon 3 bracket square plus 5. Now the after simplification, you are getting the k upon 3 is equals to plus or minus root of 21. Now therefore k is equals to plus or minus 3 root of 21, and the option A is correct one. Question number 35. If the m1 and m2 are the slopes of the tangent to the circle x square plus y square is equals to 4. The standard equation, the center is 0 from the point, that is a 3, 2. Then find the value of the mod of m1 minus m2 is equals to. And what is the value of that m1 minus m2? That the equation of the tangent through the point P x1 y1, that is written as, that is the equation of the tangent from the outside point, that is y is equals to mx plus or minus a in under root of 1 plus m square. Now this point, that is a point 3, 2 lies on this tangent, on this line. It satisfies the equation of the tangent, equation of that line. Therefore here a is equals to 2. Substitute the value of x is equals to 3, y is equals to 2, then you will get, that is a 2 is equals to 3m plus or minus 2 in under root of 1 plus m square. Now again this can be written as 2 minus 3m is equals to plus or minus 2 in under root of 1 plus m square. Now squaring on both sides, that is a 2 minus 3m bracket square is equals to 4 in bracket 1 plus m square. Now after the squaring this, that is a minus b bracket square, that is 4 minus 12m plus 9m square, and that is equals to 4 plus 4m square. Now after the simplification, then you will get 5m square minus 12m is equals to 0. Therefore, as m is, take the m is common from this, then you will get m1 is equals to 0. And after the solving, that is a 5m minus 12 equals to 0. That will be the second equation, and that is m2 is equals to 12 upon 5. This is a simple quadratic equation. First value of the m1 is 0, m is 0, we split as m1, and the second root is m2 is 12 upon 5. We want to find out the value of the mod of m1 minus m2, that is a 0 minus 12 upon 5, that is equals to 12 upon 5. Now next, the solution of the differential equation 3xy plus y square into dx plus x square plus xy into dy equals to 0 is, that is x square in bracket 2xy plus y square equals to c square, x square in bracket xy minus y square is equals to c square, x square in bracket x square minus 2xy equals to c square, and last is none of this. Now to solve this is again the homogeneous equation, because the degree of this x is 1 and 1 plus 1 is 2. That is, we can write it in this form: dy by dx is equals to minus 3xy plus y square upon x square plus xy. This is the equation number 2. Now here is a substitution, that is y is equals to vx. Differentiate dy by dx. Product rule. Derivative of x is 1, therefore here is a v plus x into derivative of v is dv by dx. Now substitute this value of the dy by dx in the equation number 1. It becomes like this, that is a v plus x dv by dx, and the substitute the value of, that is a y is equals to vx here, y is equals to vx, then you will get this is a vx, and simplification you will lead to the following steps, that is a v plus x into dv by dx. Take the common, that is x square is common from the denominator and the numerator, then you will get 3v plus v square upon x square in bracket 1 plus v, and x square get cancelled, then you will get v plus x into dv by dx minus 3v plus v square upon v plus 1. Again the next step is a minus v here from the left hand side, that is a minus v, minus in bracket 3v plus v square upon v plus 1, and the simplification leads to these steps, that is x into dv by dx is equals to minus 2v in bracket v plus 2 upon v plus 1. Therefore, now use this variable separable method, that is a v plus 1 upon v in bracket v plus 2 into dv, that is equals to minus 2 dx upon x. Now integrating on both sides, that is integral v plus 1 upon v into v plus 2 into dv, that is equals to minus 2 integral dx upon x plus log of c. Now again, what is the integral of this? That is a log of x, that is a minus 2 log of x plus c, and this treated as I. Now to find out the integral of this, we apply the partial method, that is a v plus 1 upon v in bracket v plus 2, that is a upon v plus b upon v plus 2. Cross multiplication, v plus 1 is equals to a in bracket v plus 2 plus b. Now find out the value of the a. To find out the value of the a, put v is equals to 0, then you are getting the a is equals to 1 upon 2. Put v is equals to minus 2, then you will get the value of the b. Therefore, minus 2 plus 1 equals to minus 2b. Therefore, b is equals to 1 upon 2. Now here substitute the value. What is the value of a? A is 1 upon 2 here, and b is equals to again the 1 upon 2. Now integrate. Take 1 upon 2 as common, then you are getting the integral in bracket 1 upon v plus 1 upon v plus 2 dv. Now what is the integral of 1 upon v? That is a log of mod of v plus log of mod of v plus 2. Now again there is the addition of these two logs, that is a multiplication, then you will get log of mod of v in bracket v plus 2. Now next simplification. Now substitute this value of I1, that is in above equation, then you will get minus log x plus log c is equals to 1 upon 2 log of mod of v in bracket v plus 2, and that is minus log of x. Again take this log of c on the right hand side, it will become minus, that is a multiply, and next step is multiply on both sides by 2. Then you will get 2 into 2, that is a minus 4 log of x. These 2 get cancelled. You are getting the log of in mod of v in bracket v plus 2 minus 2 log of c. Now next, that is the log of c square. Now bring this to minus down on this side and the 4 log of x to the right hand side. It becomes log of x raised to 4. Now simplify this. That is the addition of these 2 logs. It becomes multiplication. That is the log of c square is equals to log of v in bracket v plus 2 dot x raised to 4. Now cancel on both sides by log and then you will get v in bracket v plus 2 into x raised to 4 is equals to c square. Now again substitute the value of this v is equals to y upon x, and after the simplification you will get the answer, that is a y in bracket y plus 2x upon x square into x raised to 4, that is equals to c square, and hence the final answer is, that is a y square plus 2xy bracket complete into x square is equals to c square, and hence the option A is correct one, which is x square in bracket 2xy plus y square is equals to c square. The order and the degree of the differential equation, that is in root of dy by dx minus 4 dy by dx minus 7x is equals to 0. It's very simple. Whenever there is a radical sign or the fraction on the dy by dx term, keep it on one side. And here, that is in root of dy by dx is equals to bring these 2 terms on the right hand side. To the right hand side, that is a 4 dy by dx plus 7x, squaring on both sides, then you will get dy by dx, square and root get cancelled, equals to 4 dy by dx plus 7x bracket square. Now simplify this. That is a plus b bracket square. In the same manner, that is a 16 dy by dx bracket square plus 56x into dy by dx plus 49x square. And therefore, the order of this differential equation is 1 and the degree is 2. And the D option is correct. Now next, if f of x is equals to in root of x minus sin x upon x plus cos square x, then find the limit x tends to infinity of the f of x is, first is 0, infinity, 1 and D none of this. Now again this is the limit, that is the x tends to infinity of the f of x is equals to limit x tends to infinity in root of x minus sin x upon x plus cos square x. Now again if you see this, divide the numerator and the denominator by x, then you will get x upon x, that is 1, sin x upon x, and again for the denominator x upon x is 1, cos square x upon x. Now as x tends to infinity, 1 upon x, this quantity tends to 0, 1 upon x tends to 0, therefore sin x upon x this becomes 0, and for the same thing is there, cos square x upon x, that is also become 0, that is therefore in root of 1 minus 0 upon 1 plus 0, that is equals to 1, therefore the C option is correct one. Now next, if the vectors I cap minus 3j cap plus 2k cap minus I cap plus 2j cap represent the diagonal of a parallelogram, then its area will be. These are the diagonal. Now to find out, this is the A bar is equals to and the B bar is equals to. Now find out the cross product, that is A bar cross B bar is equals to I cap, J cap, K cap. These are the points, coefficient of this, that is the 1, minus 3, 2, minus 1 and 2, and the K is not there, therefore it is written as a 0. After the simplification, then you are getting, that is A bar cross B bar is equals to, that is a minus 4I cap minus 2j cap minus K cap. Here's the required area when the diagonal is given, that is equals to 1 upon 2 mod of A bar plus B bar, and that is 1 upon 2, and to find out the mod of this, that is a 4 square plus 2 square plus 1 square, that is 16 plus 4 plus 1, and that is a root of 21 upon 2, and that is the B option is correct. The position vector of the points A, B, C are 2I cap plus J cap minus K cap and 3I cap minus 2J cap plus K cap and I cap plus 4J cap minus 3K cap respectively. These points are form an isosceles triangle, form an right angle triangle, they are collinear or form a scalene triangle. Now find out the value of AB. That is a 3i minus 2j plus k. That is the coordinate of the point B minus A. Then you are getting that is AB bar is equals to minus I cap. AB bar is equals to I cap minus 3j cap plus 2k cap. In the similar manner, find out the BC bar. Then you are getting the I cap plus 4j cap minus 3k cap minus in bracket 3r minus 2j plus k. And after the simplification, you are getting the BC bar is equals to 2i cap plus 6j cap minus 4k. And there you are getting this as the result. And after the next, that is AC bar is equals to C in bracket I cap plus 4j cap minus 3k cap minus 2i plus j minus k cap. And after simplification, you are getting this. Now find out the value of the AB, mod of AB. That is the mod of AB in under root of 1 square plus 3 square plus 4 square. Find out the mod of BC bar. That is the 2 square plus 6 square plus 4 square. And the mod of AC bar. That is the 1 square plus 3 square plus 2 square. And therefore you are getting in root of 40. In root of, that is a 4 plus 36 plus 16. That is the root of 56, and that is a 14 into 4. That is a 2 root of 40. And the AC bar is equals to in root of 1 plus 9 plus 4. That is the root of 14. And hence, that is AB bar plus AC bar, that is equals to mod of BC bar, and hence ABC are collinear. Now in this video, we are completing these next 20 questions. I think that you understand all these questions. If there is any query, write me. Till then, we'll see again the next 20 questions. Till then, goodbye.